let's prove the conjunction y and a given two premises. The first premise overall is a disjunction. We have the or sentential connective. The sentential connective that's outside of parentheses by default is dominant. So line 1 is a disjunction. Line 2, we have two sentential connectives outside of parentheses. We have the negation and we have the and sentential connective. But by default, in many textbooks, including the Sutton Hill textbook, the negation sign by default is the weakest of the sentential connectives, and so we interpret line 2 overall as a conjunction. So what can we do here? We're given that conjunction, so we know that not x is the case. We can simplify, so that's a good first step. And in any proof, we number each and every line, so this is line 3. We'll get not x, and we have to justify each and every line. So we're going to justify line 3 by the simplification of line 2. Notice that line 1 we have a disjunction, x or parentheses y and z, close parentheses. But we know x is not the case, so y and z must be the case by the disjunctive syllogism. Sometimes it's called modus tollens ponens. So we can get y and z by our disjunctive syllogism with lines 1 and 3. Since x is not the case, y and z must be the case. Now notice that we have the z here, and the z appears in the antecedent to a conditional. Eventually we should do some kind of modus ponens inference. Some textbooks, we can simplify the z right now for line 5. Other textbooks you only can simplify the first term, so I'm going to follow the more restrictive conventions, if you will, to get z and y through the commutative rule, line 4. And then for 6, we can get z by the simplification of line 5. And likewise, for line 2, let's use the commutative rule. So for 7, we can then get parentheses if z, then a, close parentheses, and not x, commutative rule, line 2. And then for 8, we can get if z, then a, by the simplification of line 7. So we have z is the case according to line 6. That appears in the antecedent to a conditional, if z then a. And so for line 9, we can get a by modus ponens with lines 6 and 8. We want to prove y and a. Notice that y appears in a conjunction on line 4, so we can simplify. Hence for line 10, we can get y by the simplification of line 4. We now have a, we now have y, combine them together through the and sentential connective. So for 11, therefore, it does follow. We want to prove y and a, so y and a by the conjunction rule with lines 10 and 9. And that concludes that proof.